Hello friends, here in this video we will see the design of spiral spring. Okay, now a spiral spring is consist of a long thin strip of rectangular cross section which is wound like a spiral. Okay, the inner end of the strip is fixed in the arbor. You can see in the figure the inner end of the strip is fixed in the arbor here, right, at the center, and the outer end is clamped to the drum called retaining drum, right. The winding of spiral spring store the strain energy in the spring. Okay, so it is the general introduction of the spiral spring. The uses of it: it is used for storing energy in watches, camera, toys, instrumentation, and automobile weapon, right. Uses storing energy in watches, camera, toys, automobile weapons, etc. Right. Here the simple diagram of the spiral spring is this one. Okay. Here point A and point B. Okay. Force F and the distance R. Force to the center of the spiral spring, right, is equal to R. Okay. Now cross section of the spring is spring strip is equal to its cross section area is rectangular. Okay, its width B and thickness T. Okay, and the half of the thickness is equal to Y. Okay, this distance is Y. Clear? Half of the thickness. Clear? So it is the general figure. Okay, next, the torque vary throughout the entire range. So the maximum torque is produced when the spring is fully wound. Okay, now you can see in the figure, the spring is fully wound, the force is maximum. Then the spring is fully wound, then the torque is maximum produced. Okay, due to the force is applied at the outer end A, the bending moment is set up, and which is given by M is equal to F into R. Okay, this is it is R. M bending moment is equal to force into distance, means force into perpendicular distance, generally F into R. Okay, the maximum bending stress induced in the spiral spring at point B, and it is given by the bending moment at point B is at point B. Okay, MB is equal to M maximum, right? N is equal to F into 2R. Okay, you can see force into R plus R means F into 2R, right? So F is equal MB is equal to F into 2R is equal to 2 into F into R, and F into R means force into distance is equal to T. So that's why MB is equal to 2T. Okay, so bending stress induced in the spiral spring at point B. Okay, the general equation is bending stress sigma B is equal to M max into Y upon I. Okay, so simple equation is equal to sigma B is equal to M by Z and Z is equal to I by Y. So that's why sigma B is equal to M maximum into Y divided by I, and it is equation number 1. Clear? Next, what is sigma B? Sigma B is equal to maximum bending stress. T is equal to torque applied on the spring. M max means maximum bending stress, maximum bending moment. Okay, we already find it. Okay, F is equal to applied force. Y is equal to distance of center of the spiral spring. Okay, from the application of the force, and it is equal to T by 2. Z is equal to section modulus, and Z is equal to I by Y. I is equal to moment of inertia of the spiral spring. Okay, and it is 1 upon 12 bt cube for the rectangular cross section, right? For the rectangular cross section, I is equal to 1 upon 12 bt cube. Okay, next one is b is equal to width of the spring strip and t is equal to thickness of the spring strip. Clear? And y is equal to t by 2. Okay, we already given. Okay, already see in the previous here. Okay, okay, now from equation number 1, equation number 1 is sigma b is equal to m max into y by I. Okay, so we have the value of m max, y and I. Okay, m max, the value of m max is equal to 2t, y is equal to t by 2, and I is equal to 1 upon 12 bt cube. Okay, so after finding the sigma b is equal to 12t upon bt cube. Okay, now the strain energy stored in the spiral spring, and the equation of the strain energy is equal to u is equal to t into theta as per the Castelliano's theorem. Okay, we already seen in the deflection theory. Okay, so the angular deflection of the spiral spring is angular deflection of the spiral spring is angular deflection, that means theta. And how to find theta? So we have the general equation of the bending theory is this one, sigma by y is equal to E upon R is equal to M upon I. Okay, but we require only E upon R is equal to M by I, and M is equal to also T, means torque. Okay, and R is equal to L by theta. So we use the equation E upon R is equal to T upon I. Okay, so in this equation we can use R is equal to L by theta. So the equation is, we get the equation theta is equal to T into L divided by E into I. Okay, now the value of I is put in this equation and it is 1 upon 12 bt cube. Okay, now after calculating, the solution of theta is equal to 12 into T into L divided by E B T cube radians, right? So it is the solution of theta, means a angular deflection. Okay, where L is equal to what? L is equal to length of the strip of the spiral spring. Okay, and E is equal to modulus of elasticity of the spring in terms of Newton per mm square, right? Now next we can find the linear deflection. Angular deflection, that means deflection is angularly. Okay, and linear deflection means deflection is axially, means delta, and delta is equal to theta into y. Okay, so we have the solution or value of theta is equal to 12tl upon ebt cube. Now this value is put in this equation, so we find 12tl ebt cube into y. Okay, so we have the solution is delta is equal to 12tl into y upon ebt cube. Okay, and now final we have the equation is u is equal to 1 upon 12 t into theta. Okay, strain energy, but we have the value of theta present, so this theta is put in this equation. Okay, now the strain energy stored in the spiral spring is u is equal to 1 upon 1 half t into theta. The value of theta is put. Okay, so u is equal to, we get the value of u is equal to 6 t square L upon EBT cube. Okay, so it is the design of the spiral spring. Thank you.